Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Staff Systems Engineer here at VMware. Today, we're joined by a colleague of mine, Mr. Paul Irwin. Paul is an NSX specialist as well as a senior engineer and a technical partner manager here at VMware. This is one of his areas of specialization, and Paul does an absolutely fantastic job talking about it. Recently, I asked Paul to walk through a whiteboard on NSX, but a very specific whiteboard. I asked him to talk about what happens in a double-click type environment where we're looking at NSX not just from the basics of what it can do, but also how it expands into multiple data centers, how it helps us eliminate or mitigate the need for VLANs and also physical networking segments, and how it expands our capability from a services and policy perspective as we grow. Now, inside of this, Paul created a session, and I've split it up into a couple different segments for us. The first one walks us through the core understanding and what we can do when we start to think about extensibility. And then in the second segment, we're going to be looking at how layer 2 extensibility factors into this and how we start working in ideas like procedures, policies, and other services integrations into the NSX space. I'm really excited to bring this to you, and I know you're going to absolutely love these two sessions. So without any further, let's go ahead and join Paul as he walks us through this whiteboard on NSX.
Okay, so now we can quite easily extend that layer 2 network, okay, across that second cluster, all right? And obviously doing so without having to touch the physical network. Make sense? I think everyone should be on the same page. Question?
Yeah, quick question.
Yeah.
On the required VLANs, we're still having to do those in the second cluster, but we're just adding, but it's the optional VLANs that we're able to then program from a policy perspective.
So you still need the required VLANs. The required VLANs are required to facilitate the ESXi cluster, right? You need that regardless of what you do, right? The only additional VLAN you would need is the VLAN to facilitate the VXLAN encapsulation traffic.
Yep.
Right? But all of those optional VLANs no longer required, right? Because now you can essentially create those logical networks in the virtual space, migrate your VMs off of those traditional VLANs onto those virtual networks in the hypervisor space.
Yep, that makes sense. Okay, thank you.
Okay, cool.
I think there was another question too, wasn't there? Did somebody else have a question?
Okay, if you guys have questions, please feel free to interrupt. Okay, I'm a big fan of kind of two-way dialogue when I present these things, and welcome questions, especially around NSX and networking. It's what I used to do back in the day. All right. So one of the great things about these logical networks, or these logical switches, right, these virtual networks, is when we create them, by default, they are created as isolated layer 2 network segments. All right. So what this means is I can create as many as I want. Again, I'm creating these networks. I don't have to touch the physical fabric, and I can assign any IP range that I want to these virtual networks. Okay, I can even go as far as to say I'm going to assign the same IP space to multiple virtual networks, and I don't have to worry about virtual machines having IP address conflicts between these different networks that have the same IP address range. All right, because by default they're created isolated. So an example of how and why you would want to do that, let's say for example we need to recover data from a virtual machine, right? So you recover the virtual machine from a backup, right? You don't need to go and recover that you can't recover that virtual machine to the same production subnet. Okay, let's assume it's .20 over here, this second subnet. You create an identical subnet, same IP range. We recover that virtual machine to the newly created layer 2 network. Right? It's an isolated network. So we can take that virtual machine in its recovered state, we can power it on, it can keep its IP address, all right? No problems. And we can retrieve the data off of that virtual machine. When we're done, delete the virtual machine we've recovered, delete the network, and everything carries on as per normal. And all the while, our production.20 network has remained unaffected, as have the VMs that are running on that network. Okay. Only by leveraging a distributed logical router and connecting these isolated layer 2 networks to that distributed logical router can we start moving traffic between the different layer 2 segments. All right. So the point I'm trying to make here is it's almost too easy, all right, to create networks and connect these networks up to the distributed logical router and move packets between these different segments. It's almost child's play at this point, okay? And all the while not having to touch the physical fabric. Now, again, we're not saying get rid of the physical fabric, right? We still need a mechanism to move the packets from point A to point B across the environment, okay? So we still need your switches to connect your hosts to, right? We still need the layer 3 device to route between your required VLANs, okay? And you still need your layer 3 devices to route traffic out to the gateway, out to the internet, out to other sites, and so on and so forth. So we still need the physical fabric. We're just moving a lot of the requirements that the virtual machines need off of the physical fabric into the virtual realm, all right, where it's a lot easier for us to deliver those capabilities to the virtual machines instead of having to rely on the physical network and the way it has been architected. So, if we wanted to, for example, scale out this environment, okay, scale it out to, say, another site, all right, how could we do that? And this is the point of the presentation where I'm actually asking you guys a question. What is a way that we could scale NSX out to another site? Could we simply stand up another cluster and have vCenter manage that cluster with the same NSX manager? Could we do that?
I think it's no. NSX manager per vCenter.
Correct. One NSX manager per vCenter. But my question is, can we have a cluster at a remote location that is managed by that vCenter and NSX manager at another location?
Yeah, I would say we could, as long as we had the bandwidth necessary to do that, right?
Correct. Okay, so yes, we absolutely could, all right? So a scenario for that would be like a robo environment, okay? So big headquarters in the center, a lot of little robo offices out there. You don't generally have your vCenter at the robo offices, right? You have your vCenter at headquarters, managing the cluster at those robo locations. Well, we can leverage vCenter and NSX manager at headquarters to extend the virtual networks to the, well, I should say the virtual networks and the security policies and the security groups and all the goodness that NSX brings to those remote sites, okay? We can absolutely do that, all right? But what if we wanted to build out an environment for disaster recovery purposes? Could we leverage that same approach using a single NSX manager and vCenter?
So I would say yes, we could.
We could, but this was kind of a loaded question, right? In there I said for disaster recovery purposes. Now think about it, right? If I have one NSX manager, one vCenter at site A, and I want to create site B as my DR site, but site A blows up, well, I've just lost my vCenter and my NSX manager. I can do nothing at that point at site B. Okay, so essentially in this case, for site B, if we're building out an environment for DR, we can still leverage NSX, all right? But the point is we have to deploy a new vCenter and a new NSX manager. Again, going back to what you guys just said, one-to-one relationship between vCenter and NSX manager. That doesn't change, okay?
So, a quick question: in the vSphere 6, when we're enabling sort of stretch DRS, is there a component of NSX that's embedded in there that allows that, or what is that requiring you to have a vCenter on the other side in order to do that stretch DRS?
Okay, so we can't do stretch DRS because DRS is cluster specific, right? But we can do stretch, we can do cross vCenter vMotion.
Okay.
Right?
Okay.
And that's kind of what I'm building up towards here. So
okay.
I like the way you're thinking, but hang tight, we'll get there.
All
okay?
right.
Cool. All right. So site B, we need to deploy new vCenter, new NSX manager, because we're leveraging the site for DR purposes. Okay. So we go ahead, we build that out, everything gets plumbed in, the required VLANs. Okay, we install NSX, VTEPs go in, distributed logical router goes in. We're ready to rock and roll at this point. Okay. Now, prior to NSX 6.2, right? If we wanted to have these same layer 2 networks, okay, or we wanted to have the same security policies and security groups in Site B as what we had in Site A, we would have to manually go and build those objects in Site B. All right. Version 6.2 of NSX has given us some really cool new capabilities called universal objects. Okay. And universal objects are objects that can span beyond the boundaries of a single vCenter and a single NSX manager. Okay. So some of the objects that can span across those NSX managers include distributed logical router, distributed firewall, logical switches, transport zones. But you have to specifically create the universal logical switch, or the universal distributed firewall, or the universal transport zone. You cannot leverage the regular transport zone. Now, I'm going to take a step back here quickly. All right. In this scenario, where we want to share these universal objects between NSX environments, okay, we need to configure NSX in kind of a pairing kind of role. All right. So one NSX manager becomes the primary NSX manager. And we can have up to 7 additional NSX managers connecting to that primary NSX manager as secondary or subordinate NSX managers. Now, that primary NSX manager is responsible for creating the universal objects that can span across those NSX managers. However, each NSX manager is still capable of creating its own local objects pertinent to the vCenter environment it is managing. Okay, very important to understand the difference there, right? One guy is the big chief from the universal object standpoint, but all of them can create their own distributed firewalls, logical switches that are local to that deployment of NSX. Okay, so with these new universal objects in place, and configuring NSX appropriately, we're now able to span these layer 2 networks beyond sites, beyond vCenter boundaries, beyond NSX manager boundaries. So now it becomes possible to take those layer 2 networks, extend them into Site B, and leverage technology like Site Recovery Manager, for example, right? To automate the failover of virtual machines in the event that something fails in Site A, right? One of the biggest challenges with SRM, I shouldn't say challenge, but one of the considerations, I should say, not with SRM, but with any disaster recovery plan is, if I'm failing over a virtual machine from one site to another site, generally that second site is going to have a whole different IP range, right? And if I have an application that is sensitive to having its IP changed, maybe I have some licensing that is bound to the IP address of the virtual machine or the application, and now I have to change that IP address when it moves over to the recovery site, I'm going to run into problems. All right. So now NSX and SRM very, very tightly coupled, where we can take the virtual machine and simply bring it up on the same network at the destination site that it was on at the primary site, right? So gives us a lot of capabilities. It also gives us the ability now to really realize this whole cross vCenter vMotion capability. So now we can truly vMotion a virtual machine from Site A to Site B. All right. Obviously, as long as we meet the round trip time and the latency requirements for that long distance vMotion, we're not able to do that. Okay. So a lot of capabilities, a lot of doors now open to us by being able to leverage this universal stretch capability that NSX 6.2 is able to deliver to us. Something else I just want to point out here is we haven't had to touch the physical fabric. The only thing we've plumbed in on the physical fabric is the required VLANs we need to make the cluster work, right? We haven't touched anything on the physical fabric from a virtual machine standpoint. We haven't had to tell the physical network about any virtual machine networks that we need at both sides or one side. We're significantly decreasing the amount, I don't want to say reliance on the physical network, because we still need it, but we're able to achieve so much more at a far rapid rate in the virtual space than we ever were able to achieve leveraging the physical network fabric. Okay. Everyone with me so far? I'm assuming yes. But
yes.
Okay. Yeah. You guys are either way asleep or you're getting it, or somewhere in between. So that's okay. All right. So let's talk about these things called security groups and security policies here. So what do we know about security groups? All right. Security groups are NSX constructs that allow us to group virtual machines or applications together that have some kind of relationship dependency between them. Right. So maybe the VMs have a relationship with one another. Maybe they have some kind of similar security requirement, and we have to group them together, right? So security groups give us a couple of capabilities. We can either statically assign virtual machines to these security groups, or we can dynamically assign them. And for dynamic assignment, we have a number of options available to us as to what and how we want to assign these virtual machines to this group. So we can determine what VMs get joined to a group either by leveraging the virtual machine name. So for example, let's say we want all of our web servers, right, part of a single security group. We can say any virtual machine that has web server in the title, in the name, automatically added to the security group, right? Or we can say, any virtual machine out there that is a specific operating system added to this kind of security group. And an example that I like to use from an operating system standpoint is Windows 2003 servers, right? There's still a lot of them out there. I think, much to Microsoft's discussed, for various reasons, all right? Either applications cannot be migrated off them, or there's legacy apps that are just no longer supported by the vendor, and there's no new version. Whatever that reason may be, there's still a lot of legacy OSs out there, right? We want to be able to protect those applications running on those legacy VMs, all right? Because Microsoft isn't releasing patches for those 2003 servers anymore, so I guess us as IT admins, we have to do our part to protect those VMs. So the easiest way to group them together, to apply security to all of them at the same time, is to have them added to a single security group, right? Instead of having to go through the environment and try and figure out which VM is 2003 and what version of 2003 and etc. Just specify the OS requirement is 2003, they automatically group together in a single security group, right? And then another option we have available to us is leveraging security tags. And security tags are kind of a dynamic tag that can be written to the properties of a virtual machine, dynamically, right? So an example I use here is if a virtual machine is flagged by some antivirus software as having a virus or some kind of exploit on it, that security software can write a tag to the virtual machine, all right, that would automatically cause that virtual machine to be moved to another security group that has that dynamic requirement of that specific tag on it. Okay, and this is generally how we leverage some of our ecosystem partners within the environment. Is they do the scanning, they identify something on the VM, they write a tag to the VM, NSX identifies the tag, pulls the VM out of the security group it's in, moves it into an isolated security group with specific security policy assigned to that security group, and then we can take remediation action against that virtual machine while keeping it separate from the general population. Right? And of course we have the ability with security groups to either provide specific includes or excludes as to what VMs must be included or should be excluded from that dynamic population, right? So that's security groups, all right? Security policies, on the other hand, this is kind of where the magic happens, right? So this is where we specify what can actually happen to these virtual machines, on these virtual machines, with these virtual machines, right, that are part of these security groups, right? We define our typical access deny rules, right? Distributed firewall rules, this is where we assign those, layers 2 through layer 4, all right? So at the layer 2 level, at the MAC layer, all right? Layer 3 at the protocol layer, right? So TCP, UDP, ICMP, depending on the protocol. And layer 4, now we start getting granular, we can specify certain ports, right? SSH 22, HTTPS 443, port 84 for regular web traffic, etc., right? But security policies is also where we specify and configure network introspection services, right? And this is where our ecosystem partners come into play very, very heavily, all right? So here we can specify services such as antivirus, all right, or layers 5 through 7 security visibility, so next-gen firewall, right? And this is kind of where kind of Palo Alto kind of jumps into the mix, or Trend Micro jumps into the mix.
Thanks for taking time to join me today. As always, I hope you found value in these sessions. We've got a lot of great content this quarter. Be sure to subscribe for more updates and videos, and follow me on Twitter for news and updates as they happen. We also have a lot going on inside of services here at VMware. Be sure to look into some of our great new services that are available. Things like the NSX Design and Deploy service, now available from VMware. And if you're a VMware partner, you need to look into our Partner Preferred Services program, where you too can deliver VMware services and learn from our services consultants and professionals inside of our professional services division, so that you can deliver and bring true value and the ultimate in VMware expertise directly to your customers as well. For all this information and more, be sure to follow me on Twitter, and feel free to reach out, and we'll also be able to get you the information you need. Thanks again. I hope you have a fantastic day, and I look forward to talking to you again really soon.